there is one very similar to this in the packet. The difference is you will notice that this is all piecewise linear versus the one in your packet has a non-linear section in the graph. So it has a curved section in the graph. So I didn't want that to really trip you up. So we're doing this more simplified version together. And then if you want to try the other one, I'm happy to give you the answers to that and go over that as well. So can everybody see this beautiful, beautiful graph? Yes, we all see it. We're ready to go. Christopher, yes? We good? Everybody can see this beautiful graph? I want to make sure everybody's good. Somebody say something.
No. I think it's just me though. I'm gonna try to.
I can't see you either.
Come back.
I can't see it either.
You cannot see the graph. Can you see it now?
Yes.
Yes.
Okay. If you can't, maybe pop off the call and pop back into the call and see if you can see it, because we're really going to explore transformations. Now, before I discuss transformations, can anybody tell me what a transformation is? When we talk about graphs and we're talking about transformations, can anybody give me an example of a transformation? Maybe not on a Monday morning. That's okay. All right. So remember when we started building our parent functions, we said that was the most stripped down version of each of those functions. So we talked about the constant function. We talked about, for example, the absolute value function, right? We talked about the parents. We talked about the parent quadratic function. So we talked about parent functions, but we can do mathematical things to these parent functions and transform them to give you what is known as an image function. An image function is the resulting graph after I've performed transformations. Some transformations that you might recall from Algebra 2 are shifts, right? We can shift left and right horizontally. We can shift up and down vertically. So you have shifts. You also have reflections. So you can take a graph and you can reflect it across the y-axis. You can reflect it across the x-axis. And then we also have stretches. So we have vertical stretches when we make it narrower, or we have compressions, vertical compressions. Are those ringing bells? We remember those terms? So you can vertical stretches, making them more narrow, the graph more narrow. You can have compressions, pushing them down towards the x-axis if they're a vertical compression. You also have horizontal stretches and horizontal compressions, making it wider and narrower horizontally. So these are all transformations that you can apply to absolutely any family of functions. And you should be able to recognize these transformations if you have a parent graph and an image function, but you should also be able to recognize it if I give you an equation. So given an equation, you should be able to identify the underlying parent function and then describe the transformations, because these are applied to absolutely every family of functions. So we're going to start with this very interesting little graph, and we're going to first make a table of values. So the first thing we want to do is make a table of values for these points that we know on this given graph. So this is the parent that we've been given, this weird little piecewise linear continuous function. I could write this as a piecewise function and write little equations for each domain, but we're going to look at this graph just as a whole and just looking at the points and evaluating what happens when we move these points. So let's make a table of values of what we know. If I look at these, I have, okay, well, let me just give you the scale. We're counting by ones, so that might help to see those. Okay. So if I were to look at my table of values, I'm going to look at when x is -2, -1, 0, 1, 2, and 3. So I do want to use function notation to represent this information as well as ordered pairs. So I'm going to represent these in each of these. So if I look at my graph and I look at my output, remember f of x represents my output y, my range. So if I look at my input -2, when x is -2, what is y on this graph? When x is -2, what is y? You tell me. When x is -2, what is y? What is that point? What is the output? Anybody? What is this point? What is the output of that point?
The output is -1.
Is it -1?
I believe so.
But I'm up here in the second quadrant, so I went back 2 and then I went up 1, right? Isn't that +1? Eric, was that you?
Right. Yes.
Yeah, it's +1. We still a little asleep here?
Yeah.
Okay, so do you see how I'm filling out a table of values? When x is -2, y is 1. If I wanted to represent it using function notation, remember we would say f evaluated at -2 would be 1. And if I wanted to write it as an ordered pair, the ordered pair would be x -2, y 1, right? So the ordered pair is written as an x and y value. Function notation is f of x, right? So I'm going to continue to make my table of values. Let's see if you can tell me the outputs for the rest of these inputs. When x is -1, what is y?
-1.
Yes, it is, -1. So I could write this as f evaluated at -1 is -1. And again, the order pair would be -1, -1. So we've got to be able to look at the graph, write the table of values, represent it in function notation, represent it as an ordered pair. Okay, what about when the input is 0? What is the output?
2.
2, very good. And what about the output for when the input is 1?
1.
Excellent. When the input is 2, what is the output?
3.
Excellent. Ariana, you're on a roll. What about if the input is 3, what is the output?
0.
0, 0. Okay, so again, I could represent this using function notation for each of these. So just to get in the habit of function notation, so f evaluated when x is equal to 0 is 2. F evaluated at x equal 1 is 1. The function evaluated at 2 is 3. And the function evaluated at 3 is 0. And again, I could take each of these and represent them as ordered pairs. Now, we are going to use that table of values in particular a lot to explore the different transformations. Okay, so we're going to make sure that we have this table of values readily available. So I'm actually going to rewrite it, this table of values here, on the next page. Okay, so here I go. So I'm going to use that table of values. And let me go ahead and just write it up here. So x and then f of x. So let's see, I had -2, positive 1. I had -1, -1. I had 0, 2. I said 1, 1, and then 2, 3, and then 3, 0. And the reason I'm going to write this table of values is because those points we know exist on the original parent. We know those values. So I'm now going to look at each of these and try to figure out, what am I doing and what would the graph look like once I've done it? Okay, so we're going to try to identify the transformations. So what is happening? I see that there is a +2 attached to that x. So if I want to read this in terms of function notation, it is saying evaluate the function when I take each of the x values that are stated and add 2 to it. Okay, so if I added 2, right? So this is my original x, and this is key because this is what we're going to do these with a lot of different options, a lot of transformations. I know what the y is when x is -2. If I add 2 to this x, my new x is going to be what? Just for kicks, let's see if we understand this notation. So again, let me review. I know that f evaluated at -2 is 1, right? This is my x. What if I'm looking at f of x plus 2? Well, my original x was -2. If I add 2 to it, I'm really looking at f of 0, aren't I? Does that make sense? I'm just taking the x value that I know. So this x value is -2. And if I add 2 to that, -2, which was the original first x value that I had, plus 2 means I'm now looking at f of 0. You'll have to let me know if this makes any sense to you or if I'm losing you. Do you see how I'm just adding 2 to the x? Nathan? Yes? Eric? Yes? Anybody? You're making me a little nervous. Okay, let's try this again, a different way. Let's look at this a different way. Okay, we know that these are our values for our parent, right? We took that from the graph on the previous page. We know that's the parent function. We know those points exist on the parent function. Now, let's say I'm trying to fill out this table of values and I've been given different x's. Okay, so let's say I want to evaluate the function for when x is -4. I'm going to take this -4 and I'm going to substitute in there. If I substitute -4 in for that x, so what I'm really doing is I'm saying I want to evaluate, and let me make this a little bit bigger. I want to evaluate f at x plus 2. In this case, x is -4. Do you see that? I'm just evaluating this function at this x value. So I'm just taking -4 and I'm substituting in for x. If I substitute -4 in for x, what am I really evaluating? Well, f evaluated at -4 plus 2 is just f at what? What's -4 plus -2? Okay, so all I've done is I said, okay, I want to evaluate the function for these values of x. And when I substitute x in here, what am I really evaluating? For the first one, when x is equal to -4, I'm really looking at f at -2 in our original function. F at -2 in our original function is what? In our original function, if I go back to our original function, what is the function evaluated at -2?
1.
1. Excellent. Okay, now I'm going to do this for the entire first problem, but then y'all need to be able to do the other. So let's do the next one. Okay, so the next one is saying, all right, now let's look at what happens when x is equal to -3. I'm coming into this function and I'm saying I want to evaluate f at, and in this case, x is -3. So what am I really evaluating? F at what value?
-1.
-1. So I go back to my original graph and I look at what happens when f is evaluated at -1. The output is
-1.
-1. Beautiful. Now let's continue. If I want to evaluate f at this x using this function, what am I really evaluating? F at if I substitute -2 in for x, what am I really looking at in my original graph?
0.
0. So going back to my original table, what is the function evaluated at 0?
2.
2. Okay, let's keep going. If I'm evaluating this function for this x value, what am I really looking back at my original problem? What am I looking at? F at what? -1 plus 2 is what?
1.
1. And what is that output?
1.
Excellent. Now let's keep going. If I substitute in 0 for x, I'm really looking at what input in my original function? Substitute in 0 for x. So what am I really looking at? F at?
F of 2.
Beautiful. And what is f of 2?
3.
Excellent. And for the last one, I'm looking back to my original function for when the input is what?
F of 3.
Excellent. And the output is?
0.
0. So now, if I go and rewrite each of these as ordered pairs, my new ordered pairs for this function is -4, 1, -3, -1, -2, 2, -1, 1, 0, 3, 1, 0. So now I'm going to plot those points on my graph. If I plot my points on this graph, this is my x, and this is f of x plus 2. That's my y. I'm going to plot -4, 1, -3, -1, -2, 2, -1, 1, 0, 3, 1, 0. And if I connect these, how does that compare to my original function? What have I done to my original function? Well, that was my original function. What have I done to it? What does it look like I've done to that graph?
You just shifted it to the side.
Okay, I have, and you are correct, but mathematically, we would describe this as a horizontal shift, right? Left, or translation, depending on, those mean the same thing. So it could be a translation. Shift or translation mean the same thing. 2 units. So now let's go back and look at our equation. By adding 2 to the x value, I have shifted my graph, my parent function, to get this image function. So this is my image function. My image function is the graph after I've applied transformations. The transformation that I did on this graph was a horizontal shift left 2 units. We should be able to recognize a horizontal shift 2 units by adding 2 to the x. Nathan, how are you doing with this graph? I know you're not a big fan of graphing. Does this make sense?
Yes, ma'am.
Okay. Now, we're going to, again, keep this original parent function information. So this was the table of values for our parent function. And now I'm going to go through a similar process, but in this instance, what I'm going to do is I am now going to subtract 2 from each x value. So if I go, and I'm going to do we're going to see how well we can do this on our own. Okay. So if I look at our original parent at x equal -2, right? I know what the output is, but I'm not asking for that. I'm asking you to substitute in these x values. So I'm coming in here and I'm substituting each of these x values in here to identify what we're really looking at in our original problem. Once you've identified that, you come back to this table, you populate it. So can somebody tell me what is the input once I take this x value and I subtract 2 from it? What am I really looking at f, the input to f? What should go here?
-2.
Excellent. What about the next one?
-1.
And what about the next one?
0.
And the next one?
1.
Excellent. Keep going.
2.
2. And last but not least?
3.
3. So I took each of these x values, I substituted in here, then I subtracted 2 from each of them to figure out what value I am actually going to be looking at in our original. So these values are 2 less than these values. Do you see that? Okay, so now go back to our original function and give me the corresponding y's for each of those. What are the y values? You tell me. Can anybody tell me the first y value? I'm looking for the y values for these, right? So what's the first one? What is the output when f is -2? I'm just going back to this table, right? Can anybody tell me what the output is for when the input is -2?
1.
Excellent. And what about the output for the next one?
-1.
Excellent. Keep going.
2.
Mhm.
The next one is 1, and the other one is 3, and the last one is 0.
Excellent. So now I can rewrite these all as ordered pairs, right? I'm taking this input, this input, this output. So look where I am. When x, oops, not that input, this input. 0, 1, 1, -1, 2, 2, 3, 1, 4, 3, 5, 0. If I were to plot those points, and I look at that graph, can you maybe tell me what type of transformation I have made to the parent, right? We're going back to the parent to get this. What have I done? How could you describe the transformation to the parent to get the image function? What have I done to the parent? This is the image. That was the parent. What have I done? Can you describe the transformation?
Horizontal shift right 2 units.
Yeah, excellent. So again, by looking at this equation, you should be able to identify, we shouldn't have to do these table of values. You should be able to look at the equation and say, when you see x plus 2, that it's a shift to the left 2. When you see x minus 2, that it's a shift to the right 2. So you need to be comfortable enough to be able to recognize the transformation just from the equation. Okay, let's take a look at the next one and see if you can figure out what's happening. So we know that this is the y value. So what I'm saying is, given each of these x's, I'm just substituting in here, evaluating f of x, whatever that output is, I'm adding 2 to that. Okay, so if I'm looking at this, it's saying evaluate. If I'm going through the process to evaluate this, the first thing I want to do is I want to say, okay, oops, not yellow. F evaluated at -2 plus 2. I don't like that. Let's do it highlighted instead. So can you understand the notation here? It's saying the output of this function is f of x. So find that output and then add 2 to it. So what is f of -2 in our original parent function? What's f of -2? What is that? Can anybody tell me? In our parent function, we're going back, always go back to your parent. F evaluated at -2 gives me what output? Nobody wants to answer my question. Can
You
any?
know?
Well, the function evaluated at -2 is 1, right? Isn't this f of -2 equals 1? So the function evaluated at -2 is 1. So this becomes 1. 1 plus 2 gives me 3. This function is telling me to take f evaluated at each of these x's, find what the y is, and add 2 to that y. So do you see here we're impacting the x values, here we're impacting the y values. Yes, no, or maybe so. So in this next one, y'all, transformation is super important. If I take f of x, it's saying evaluate the function at -1 and then add 2 to that output. So what is the original function evaluated at -1? If I go back to the original function, which is this, what is the output for when the input is -1? We're looking right at it. What is the function evaluated at -1? Do we not see that? When x is -1, what is y?
-1.
-1. So this becomes -1. The function evaluated at -1, our parent function, f of x, evaluated at -1 is -1. Then I'm adding 2 to that. So what is my new output?
One.
Yes. Okay. Can you do the next one? I'm evaluating the function at x equals 0, and then I'm adding 2 to that output. What would the new output for the image function be?
4.
4. Beautiful. What about the next one?
3.
Very good. Okay, Christopher's got this. How about everybody else? Eric? Abiela, yes? Eric, are you understanding this? Yes?
Yes.
Okay, okay, y'all speak up. This is huge. Transformations are huge. Transformations are very important. And function notation is very important. So we have to be able to manipulate these. Okay, so y'all tell me what the output to this image, this is my image function. What is the output to the image if the input is 2? Somebody other than Christopher.
5.
Yes! Okay, what about the next one? If I input 3 into my function and then add 2 to the output, what do I get?
2.
2. Beautiful. So the corresponding ordered pairs that I will plot for my image function are these. So -2, 3, -1. That doesn't really look right. It's kind of crooked. -2, 3, -1, 1, 0, 4, 1, 3, 2, Oops. 1, 2, 3, 4, 5, 3, 2. So if I look at this, oh my, how does that graph compare to our original? Can anybody recognize what's happening? What does it look like we've done to that parent? This is the parent. So take the graph of the parent and compare it to this one. Can anybody describe the transformation made to the parent to get the graph of the image function?
The image function is shifted up 2 units.
Exactly. So it is a vertical shift or translation up 2 units. Eric, excellent. So again, if I look at the equation, you should be able to recognize that I am taking each of my outputs, each of my y values, and moving them up 2. So by looking at this equation, you should be able to recognize immediately that I've taken my parent and shifted it up 2. If you can recognize the transformation, you literally could go back to this graph and say, okay, I'm taking this point and I'm moving it up 2. Let me not do that. I'm taking this point and I'm moving it up 2. I'm taking this point, I'm moving it up 2. I'm taking this point, I'm moving it up 2. I'm taking this, I'm moving it up. I'm taking this, I'm moving it up. If you can recognize transformations by their graph, if this is f of x, and then this is f of x plus 2. So you should be able to recognize it without having to do any calculations. If I give you this graph and I say this original one was f of x, and I want you to graph this, all you have to do is take those points and move them up 2. Or if I gave you f of x plus 2, you should be able to take each of these points and move them back 2. So you should be able to recognize transformations and be able to graph them easily. So you should be able to recognize that this is that. So given a parent and given an equation in function notation, you should be able to shift the parent easily by recognizing the transformation. Does that make sense? Okay, let's do more transformations. Do you think by just looking at the equation, you know the transformation? Can you tell me the transformations without doing anything? What is the transformation that yields this image function from the parent?
Vertical shift down 2 units.
This should be a vertical shift down 2. Yes. So in essence, I'm taking each of these and I'm just subtracting 2 from each of these outputs to get these. You figure those out and let's see if we got them right. Figure out those y values. I don't care if you substitute in and do it the way we did it before, or if you go immediately to the parent function and recognize that. Makes no difference to me. You tell me what those outputs are. Transformations get a little bit more interesting on the next page. So you're finding the y values, and then you're plotting the points to see if you can see that the parent has been shifted. And I can graph the parent on here. Might as well. just for you to see. So I'm going to graph the parent from these points on here, -2, 1. That's my parent. So you can plot the parent and then shift everything down to if you want. I don't care. It's your decision how you want to do it. But you're going to give me the outputs and you're going to tell me you're going to graph it. Did we get the outputs? Yes? Y'all want to tell me what they are? Does anybody want to tell me what they are?
I think I know them.
Okay, give them to me.
So x -2 gives an output of -1.
Mm-hmm.
-1 gives an output of -3.
Mm-hmm.
0 gives an output of 0.
Mm-hmm.
1 gives an output of -1.
Mm-hmm.
And 2 gives an output of 1.
Mm-hmm.
And 3 gives an output of -2.
Excellent. Yes. So we have the points -2, -1, -1, -3, 0, 0, 1, -1, 2, 1, and 3, -2. And if I were to plot those, it is a vertical shift down 2 units. It's kind of nice. It's kind of nice. It helps to know the transformations just by looking at the equation to easily identify them. Okay, so now let's move on to the next one. Again, I'm going to take this parent function table and I'm going to write it, off to the side so that we have that available to us. So let me write the parent function table of values so we know what we have. So we had, let me go back to my table. -2, 1, -1, -1, 0, 2, 1, 1, 2, 3, and 3, 0. So we're going to use those, and now we are going to try to recognize these transformations. So we're going through the same process, and we're trying to identify the transformations. So just to kind of give you a little hint, here we're impacting the x, right? We're doing something to the x. We're technically doubling x. Here we're taking half of x. In this one, we're doubling y, right? So you have to be able to identify whether you're impacting the x or the y. So go ahead and try those. Let's see if we can get those table of values, go through the same process. You're just substituting in these x values in for x, seeing what the new function we're evaluating at. And again, here we're just taking these x values, we're substituting in for x. Here we're taking these x values, we're substituting in for x. So here we're trying to find f of a new y. Here we're taking 2 of the output, 2 times the output, right? So one we're evaluating the x, one we're evaluating the y. Or we're modifying the x versus modifying the y. So go ahead and try to do those. If you are stuck, let me know. Don't just sit there not knowing what to do, but I want you to try these and then see if you can recognize the transformations. Out of curiosity, if you've never seen transformations, you've never talked about these shifts and stretches and reflections, raise your hand in teams. If you've never seen this, otherwise, you should know this. So everybody's seen it. Okay. You just didn't necessarily master it the first time around, right? If you need to discuss with each other, by all means, say, hey, did anybody get this or that? Feel free to discuss them.
Ma'am,
Mm-hmm.
I need to leave early.
Yes, I know. Did you get my response to your message?
Yes, ma'am.
Okay, so yeah, you do what you need to do. That is fine. But Nathan, these transformations, these graphs, I know you need the practice, so make sure that you look at those, the video. So I understand, I know, yeah, that's fine. When you have to go, you go. But please make sure you master these.
Yes, ma'am.
Okay.
Have a good day.
You're welcome. Bye. You too. Aurelia, is this making sense? Y'all let me know if you get stuck. I'm hoping at the end of this to do a little Desmos activity where you play against each other. So let's make sure we know this as well as we can. When you have finished this page, if you feel like you got it and graphed it and can recognize the transformation, feel free to move on to the next page. If you're stuck, please let me know. But feel free to keep working on these. If y'all want me to go over any answers to make sure that you're on the right track, of course, I'm willing to do that, but I don't want to rush anybody. Once you have finished number 5, number 6, and your number 7, please raise your hand in teams so I know that you've done those 3, and then maybe we can go over them. But I don't want to go over them until everyone's had a chance. So when you finish 5, 6, and 7, raise your hand in teams, please.
Miss, can you help me with number 5?
Absolutely, absolutely, absolutely. Okay, so what we're doing in number 5 is we're taking each of these x values and we're substituting in here. Okay, so what this is saying is originally I'm going to go back to my parent, but I'm going to look at f evaluate. Oops, let me take it off the highlighter. F evaluated at 2 times this x, which is -1. Do you see? I'm just substituting this value in for x. So then I'm really evaluating the function at what? 2 times -1 is what? Do you see, Ariana? All I'm doing is I'm taking the x value, I'm substituting in here. So 2 times this -1 gives me what? The function evaluated. What's 2 times -1? Bless you. Can you tell me? So I've taken this x.
Is it -2?
It is -2. It is absolutely -2. So by evaluating this new function, I have taken the x that has been given to me in the table. I'm multiplying that x by 2. I'm doubling that x. And then I'm going back to my original function and I'm saying the output for this x in this function is the same as the original function evaluated at -2. The original function evaluated at -2 has what output?
1.
Excellent. Okay, so now I'm doing that. So this gives me the point -1, 1, which is on my image function. Now I'm going to do the same thing. I'm going to take this x. I'm going to substitute in here. I'm in essence doubling it, right? I'm multiplying it by 2. So then the function here is 2 times this x value, which is really the function evaluated at what? What's 2 times -1/2? Oops, sorry. What's function 2 times -1/2? What's 2 times -1/2?
I'm not really good with fractions, Miss.
Well, let's do it. Let's do it. If I take 2 times -1/2, this is 2 over 1 times -1/2. When you multiply fractions, you multiply the numerators, you multiply the denominators. Okay? So if I multiply my numerators, what am I going to get? What's 2 times -1? What's 2 times -1?
It's -2.
Okay, and what's 1 times 2?
2.
Okay, and can I simplify that further? What's -2 divided by 2? I can't hear you. 2 goes into 2 once, 2 goes into 2 once, so that's negative 1 over 1, which is just negative 1, right? Do you see how that's negative 1? Okay, so then I'm really, the output to this function, when I take 2 times this input, is the same as the our parent function evaluated at negative 1. What is the output in our parent when the input was negative 1?
Negative 1.
Absolutely. Okay, so that's going to give me the point negative 1/2, negative 1. Okay, so now let's do it again. So I'm evaluating this function at 2 times this x value. So I'm really doing the function evaluated at what?
Would you say, Miss?
So if I'm taking this x value, right, and I'm substituting it in here, right, I'm evaluating the function at 2 times 0. What is 2 times 0?
0.
0. So now I come back to my parent and I say, what was the output when the input was 0?
2.
Exactly. Okay, so let's keep going. Okay, now I'm evaluating the function at 2 times 1/2. Here we go, another fraction, but you can do it, right? So now I'm saying 2 times 1/2. What does that simplify to? What's 2?
1.
Yes, you got it. Okay, so I'm really looking at my original function for when my input was 1. What was my input?
1.
Beautiful. Yeah. So now I have 1/2 1. Let's keep going. Okay. So now I'm looking at the function at 2 times this x value. So I'm really looking at the function evaluated at what input? What do you think?
Two.
Yes. Okay. So then I go back to my parent and I look at for the output for when the input was 2. And what was the output?
3.
Excellent. So there's my new point on the image function. Here we go with another fraction. You can do it. Okay. So the function evaluated at 2 times this is really, okay, so now I'm doing 2 times 3/2. What is 2? What's ugly? What's 2 times 3/2?
Uh, 4.
Well, I'm multiplying
And,
the numerators. If I multiply the numerators, what am I going to get? 2 times 3 is
6.
over 1 times 2, which is
2.
okay, and then 6 divided by 2 is
4.
no.
Oh, wait.
2 times 1 is 6. That's okay. 2 times 1 is 2. 2 times 2 is
2 times that's 3. My bad.
Okay, so this is 3, right? Okay, so I'm really looking at the function evaluated at the input is 3, which what is the output?
0.
0. Okay, so now I have another point. Now if I plot those points, I'm going to plot these. And if I plot these points, I have -1, 1, -0.5, -1, 0, 2, 0.5, 1, 1, 3, 1.5, because 3/2 is 1.5, 0. So what does it look like I've done to my parent? Well, let me go ahead and graph my parent underneath so you can kind of better see it. So if I were to plot my parent, this is my parent. What does it look like I've done to the yellow one to get the black one?
It's been compressed.
It's being compressed, right? It's being squished. It's being squished. Okay. So this is in fact a compression. It is a compression. It's a horizontal. Oh, let me not do that in yellow because the image is black. And you may have heard shrink by a factor of 2. The image. So if by multiplying the x by 2 gives you a horizontal compression, what do you think multiplying the x by 1/2 is going to do to the image, to the parent to get the image?
It's going to stretch it?
Yes. This will be a horizontal stretch by a factor of 1/2. And then we have to think about the other. So y'all keep working. If you need to take a tiny little break and use the facilities, that's fine. But let's go ahead. Ariana, let me know if you still need help on these. Natalie, I see you finished these 3. Move on to the next one. Let's try to see what happens. I'm going to go ahead and graph the parent on each of these, just so we can look at them in relationship to what's happening to the image. So I'm graphing the parent on each of these because sometimes it's easier to see that way. So there's the parent. And there's the parent on that. So let's go ahead and finish the rest of this packet. When you think you've got an idea of what each of these does, go ahead and see if you can write a summary for each of them. Okay, so eventually we're getting to the summary page. But we're still on this one. Okay, Abiella's now, you're finished with this page. We're moving on to the others. Okay. So again, once you finish 5, 6, and 7, let me know. We can go over these answers. But the rest of you, once you finish these, feel free to move forward and finish this worksheet. I wanted to do a little Desmos game, but we may have to save that for tomorrow, depending on when we finish this, going over this. And let me get my little puzzle to end with, because I like to end with a little puzzle. We did the flower. We did the cherry. We'll do this one. Let me know if you get stuck. Abiela, are we okay?
Yeah, my phone's just being weird.
Okay. Ariana, is it making sense? Do we need a little help on this one, or are we doing okay?
No, I got it. I just need to figure out one more.
Oh, good. Okay. Shall we go over the rest, the number 6 and number 7 in their entirety, and then we continue on with the rest? Okay. So let's talk about what the output would be for number 6. For number 6, can you tell me, Natalie, what are the output values?
I just realized. Okay.
It's okay. You realize what? What?
Oh no, I said I just realized that my mic was on.
Oh, that's okay. That means you get to tell
for
us the output value.
For the Y values, I got. Oh wait. Wait. Could you repeat what you asked me again? Because
Yes,
now I'm confusing myself.
the output values for number 6 that correspond to
Okay.
these input values? What are the output values?
The output values I got were 1, -1, 2, 4, 3, and 0.
Okay, I don't know about this one. Let's check this one. If I substitute in 2 for x, I'm really evaluating f at 1, right? F at 1 is what? 1, right? That's the only one I don't agree with. You see why it's 1?
Did I say something else? Because I have 1 written down.
You said
Next
4,
to-
unless I heard something else. I heard 4, but it's 1. But yeah, you're right if you said 1. Okay, so if I plot these points, we said this should be a horizontal stretch. So let's see if we see that. 1, 2, 3, 4, 1. -2, -1. 0, 2. 2, 1. 4, 3. 6, 0. Yeah. You see how that's been stretched out from the y-axis? Good. All right. Who would like to tell me number 7? Abiella, were you able to get the outputs for number 7?
Yes, I think they're right.
Okay, can you tell me what you got?
I got 2, -2, 4, 2, 6, and then 0.
Excellent. And if I were to plot these, -2, 2, -1, -2, 0, 4, 1, 2, 2, 6, 3, 0. What is the transformation that you are seeing? What is the image function a result of doing to the parent?
Vertical stretch.
Yes, it is a vertical stretch by a factor, because we're multiplying, of 2, right? So that little 2 on the outside is impacting the y. It's 2 times the y values. So the y values are being twice the value of the original parent. Good. Excellent. Shall we move on to the next page? Okay, I'm going to put your hands down. And then if you have finished this page, as soon as I lower your hands, I have to lower every single one. Lower hand, lower hand. Okay. Once you finish 8, 9, and 10, raise your hand in teams. But of course, by all means, feel free to continue on with 11 and 12. I am going to write the parent function values at the top. So this is for the parent. I should have these memorized by now, but I don't. -2, 1, -1, -1, 0, 2, 1, 1, 2, 3, 3, 0. So those are the parents. And then I'm going to graph the parents on each of these just for you. So once you finish these three, raise your hand in teams. Let me know if you get stuck.
Miss,
Yes.
is that 1/2 in front of the F? Like, is it important or
Is it what?
is it important? Because in
Yes.
the other problem, the
So-
1/2 was behind. Or like, yeah.
Not behind. So here, the 1/2 was attached to the x, right? So we're first taking half of these x values, right? And then evaluating the function at the new x value. Here, I'm evaluating the function at each of these x values and then taking half of that output, right? So one was impacting the x. We were taking half of the x. In this case, we're taking half of the y value, right? So we're evaluating the function. We're first evaluating the function and at each of these x's. And then once I get that, I look to my table, right? And I find f of x. And then I take half of that value. So it does make a difference. If the half is on the inside, the input, we're impacting the x's. If the half is on the outside, we're impacting the y's. Do you see that? Okay, shall we do the first one together to make sure we understand? Okay, so here it's telling you to take 1/2 of the function evaluated at -2. So I first find what is f of -2. I go back to the table and I say when the input is -2, what is the output?
1.
1. So this whole thing becomes 1, right? So what's half of 1? 1/2 times 1. Well, anything times 1 is itself, so what would this be? What's 1/2 times 1? One half times 1. Multiply the numerators, multiply the denominators. If I'm
1/2.
1/2. Then I'm going to do the same thing again. I'm going to evaluate the function at this x, go to the table, find the output, and then take half of it. So I would be finding 1/2 of the function evaluated at -1. So I have to first find the function evaluated at -1 and then take half of that output. So once you finish this page, 8, 9, and 10, raise your hand in teams. And we will go over this page. But keep going, keep moving forward. Ooh, we're getting it. Eric, Christopher, y'all are doing okay?
Yeah, I got the table. I just need a graphic.
Yeah.
Okay, and you're recognizing the transformation? These are important, these transformations. Ooh, you should just be able to do them like that. Okay, keep working. I'm going to run to the restroom real quick. I'll be right back.
Does anyone understand 11 and 12?
What part of it?
No, I didn't get those either.
Okay, because it looks confusing and I just got lost.
You mean the symbols?
Yeah, the symbol.
Yeah, that's absolute value. That's so like no matter what number you get, so let's say you have -2, it turns it to 2. It just turns it to a positive number.
Oh, okay, thank you.
No problem.
That was beautiful. I didn't want to come back in the room because I was listening to y'all. That was absolutely beautiful. I love asking questions, answering questions. Y'all are fantastic. Okay, let's go over 8, 9, and 10, and then I'll let you continue to work on those last ones that y'all were working on. Okay, for number 8, that was just so music to my ears to hear y'all discuss that. Okay, number 8, can you tell me what the corresponding output values would be for each of these input values? On number 8, we said the first one was a half. So when x is -1, can somebody tell me what the output is?
-1/2.
-1/2. What about 0? Keep going.
1.
Mm-hmm. Keep going.
1/2.
Mm-hmm.
1.5 and 0.
1.5 or 3/2, either one, whether you want a decimal or improper fraction, it doesn't matter. And last but not least, when x is 3, y is, you said
0.
0. Okay, so if I were to plot those, -2, 1/2, -1, -1/2, 0, 1, 1/2, 2, 1.5, 3, 0, what is happening here? How would we describe number 8? How would we describe the transformation that has been made?
Vertical compression?
Yes, it is. You are absolutely compressed. Absolutely correct. Vertical compression or shrink by a factor of 1/2, right? Good. Okay, what about my output values for number 9? Number 9, what would the output values for number 9 be? The first one?
1.
Is it 1? For number 9?
0.
0. Do we see why it's 0? So I'm evaluating f at -3. So that's f at +3. The function evaluated at +3 is 0. Do we see that? Yeah, okay. Keep going. What about the rest of the output values? For -2, what is y?
3.
Keep going.
1,
Mm-hmm.
2,
Mm-hmm.
-1, and then
Beautiful, beautiful. So here's my parent in green. If I were to plot my image function, oops, sorry, I did that one wrong. -1, 1, 0, oddly, 0, 2, 1, -1, 2, 1. That is the most awful graph I've ever seen. I did a terrible job graphing that. I did a terrible job graphing that. What has happened there? What does that negative do inside? Actually, I graphed it wrong. Let me, I read the negative wrong. -3, 0, -3, 0, -2, +3, -1, +1, 0, 2, 1, -1, 2, 1. That should be better. What on earth has happened there? Can anybody tell me what this negative attached to the X has done? What transformation is that? What does it look like?
horizontal reflection.
It's not a compression.
I said reflection.
Oh, reflection. It is a reflection, but when you define reflection, you say it reflects across what? Or reflects about what? It's a reflection across the y-axis, isn't it? Do you see how this point is this point? This point is this point. Do you see how it's a reflection across the y-axis? Everything that is a positive x, let's not do it with that. Everything that is a positive x has been negated. So all my positive x's have become negative. All my negative x's have become positive. So do you see why by putting the minus sign in front of the x, we're changing the x values to their opposite sign. So that's why it's a reflection across the x-axis, because the negative is in front of the x. Does that make sense? So by looking at this equation, can you tell me what the minus sign in front of the f of x would do? What type of transformation can you tell me automatically without looking at the graph? What would that be? The minus sign in front of the f of x.
Reflection across the x-axis.
That is absolutely correct. Absolutely correct. Why? Because I'm taking each of these y values in our original function and I'm taking the opposite. So if my y was positive, it's now negative. If my y was negative, it's now positive. So it's a reflection across the x-axis. So I really don't even have to do any work. I could take this x and move it here. I could take this x and move it here. I could take this x, move it here. I could reflect every single one of these across the x-axis. Do you see that? So all I'm doing is I'm negating the signs for each of these. Does that make sense? There's shortcuts to all of these. We got those? If any of this didn't make sense, let me know now, because we're moving on to other transformations. Now, all of these transformations work with all of the functions that we've talked about and will talk about. So you should be able to recognize these transformations no matter what equation I give you. Okay, so now let's look at the last set. The last set Ooh, and I heard it. I heard y'all talk about it when I was in the other room. These bars with respect to functions or real numbers mean what? I heard you say it. I heard somebody say it. What do those parallel lines mean? Absolute value. And we know for the absolute value function, if the input is positive, we keep it. If the input is negative, I should say positive or equal to 0, then we take the opposite. So in essence, the end result of taking the absolute value of a number is always positive, right? So here we're evaluating the function and then taking the absolute value. Here we're taking the absolute value of x and then evaluating the function. So I'll go ahead and write those original parent functions, values, in case you didn't write them down. So I'll graph my parent, -2, 1. These are harder. These two are a little harder. Let's see if you can figure out and describe the transformations. Eric, you got them? These are
Yes,
these are a little interesting here. These are a little interesting. These are little extensions. These are challenges. Once you think you've gotten all of them, go ahead and summarize your findings. In other words, if you are given a function and you're adding a to the x versus adding a to the y versus multiplying the x by a versus multiplying the y by a, negating the x, negating the y, see if you can describe, summarize your findings. Once you've done 11 and 12, raise your hand in teams so we can go over it and then continue to work on summarizing your findings. Raise your hand once you think you've gotten 11 and 12, and then summarize your findings. Christopher, Natalie, we're doing okay? Natalie got them. Christopher, Ariana, are we getting number 11 and 12? Once you've finished 11 and 12, raise your hand in teams, but move on to the summary and see if you can automatically determine the summary for each of these transformations. If not, go back and look at them and write down your summaries.
I'm not really getting number 11.
Okay, number 11. Let's look at number 11. Let me erase what I have so far and go through it. Okay, so you are being asked to find f of x and then take the absolute value of it. So are you familiar with these, what the absolute value is, right? Okay, so for the first one, it is saying that y equals the absolute value of f evaluated at -2. I'm taking this -2 and I'm substituting in for x. So I'm first evaluating f of x. So f of x, the inside, is f of -2. What is f of -2 in the parent? The function evaluated at x equal -2. In the parent, what is the y?
1.
1, absolutely. And then I'm going to come back in here and I'm going to say, all right, y equals the absolute value, and you said of 1. What is the absolute value of 1? 1. Absolutely. So now I'm going to do the same thing to the second one. So the second one is saying, all right, for when x is equal to -1, I'm going to go through the same process, and I'm going to say y equals the absolute value of f of x. In this case, x is -1. So I first find f of -1, and then I take the absolute value of it. So f of -1 is what? What's the function evaluated at x equal -1? When x equal -1, y is -1, right? Ariana, does that make sense? Okay, so then all I have to do is take the absolute value of -1. What's the absolute value of -1?
1.
1. So if you notice, all you really are having to do is you're just looking at these output values and you're taking the absolute value of them. So what would be the next one? If I were to evaluate y, where it's the absolute value of f of x, what's the absolute value of f of 0?
2.
What is the absolute value of f of 1?
1.
Okay, what is the absolute value of f of 2?
3.
And the absolute value of f of 3?
0.
Okay, so now if I plot those points, if I now look at my image, -2, +1, -1, +1, 0, 2, 1, 1, 2, 3. So what's happened? What's the only thing that's changed? Can we recognize what's happening in the image? How would we describe that? Well, this didn't change. 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 The only one that changed is this point. Why is that the only one that changed? Can anybody tell me? Abiella, you look like you want to tell me why that one is the only one that changed.
Because it was a negative, right?
It's a negative. So if I take the output, these are y values, right? So I'm looking for when my y is negative. When my y is negative, when I take the absolute value of that, it makes it positive. So how would I describe this? All negative y values become positive, right? Positive y values stay the same. Okay, now in the next one, you're first taking the absolute value of x. So you're taking the absolute value of x, and then you're looking at the function at that new x value. So the first step in number 12 would be to take the absolute value of -3. What is the absolute value of -3? What's the absolute value of -3? Abiella, do you know what the absolute value of -3 is?
0.
No. What's the absolute value of -3?
Oh,
That's the output. Abiella, you went 2
Yeah.
steps ahead. So the absolute value of -3 is 3. The function evaluated at 3 is 0. So yeah, you answered the output. Okay, so you're first taking the absolute value of each of the inputs, right? And then you're finding the function evaluated at that new absolute value. So we're still waiting for Christopher and Ariana to finish that last one, and then describe to me what's happening. And then we'll go over the summary. So this first one would be f of 3. Okay. So tell me what the outputs are for number 12. So when x is -2, we're evaluating f at 2. So what's the output? Can somebody tell me? Anybody? Christopher? 3. Is that correct? When f is, absolutely. What about when x is -1? What is the y value of the image function? Do we get it? What's the output for when x is -1? That's really,
1.
Yes. Okay, what about 0?
2.
Yes. What about when x is equal to 1?
1.
And 2?
3.
And 3?
0.
So if I were to plot these, -3, 0, -2, 3, -1, 1, 0, 2, 1, 1. Boy, I made that one too high up. And then 1, 1, 2, 3, 3, 0. So what is happening here? Can you describe what is happening here? It's kind of a weird description. Can anybody put it into words? What's happening here? It's not going to be something as easy as, oh, it's shifted to the right 2. How would we describe what's happening to the parent? What is happening? If I look at that graph, how would we describe that? Well, none of this changes, right? This all stays the same for the parent and the image. The only thing that is changing is that this part is being reflected over the y-axis. So the points that have positive y values are reflected, right, across the y-axis. Do you see how only the first quadrant is being manipulated? We're kind of ignoring all of this here. Okay? So hopefully you're able to get that graph. All right. Are we ready to discuss the findings? Do we need more time for the findings? Can you quickly go through those and describe the transformations being made to each of them easily? I'm trying to lower hands. Okay, I'm going to just call on people and I want you to tell me what transformation is being represented. Do you need more time to do this or are we okay to go over it? Have we done the transformations? Can you tell me? If I were to add A to X, Ariana, can you tell me the transformation? What is happening when I add A to X? Can you describe the transformation? Can anybody describe the transformations? If you're given a function and you're adding A to X, what is that doing to the parent? Eric, Christopher, Abiella.
The shift,
What kind of shift?
horizontal.
Okay. If A is greater than 0, making that positive, it is a horizontal shift left A units. If A is negative, right? If A is negative, so that would be X minus A, right? Then that would be a horizontal shift right. Does that make sense? You see how I kind of split that into whether A is positive or negative? Okay. What about this plus A here? So I'm taking the function, evaluating it at an X, and then adding A. If A is positive, can you tell me what is happening to the graph of the parent? If A is positive here,
There's a vertical shift up.
yes, vertical shift up A units. Similarly, if A is negative, it is a vertical shift down A units because it's impacting the Y. All right, here we go. What about if we are multiplying the input by A? What's happening if I'm multiplying the input by A? Well, there's 3 instances here. A can be what? Greater than 0, and let me go ahead and put absolute value. Or A could be a number, it could be a fraction. Let's take that into consideration. And then what if A is negative? Can you tell me what's happening in each of these instances? If A is a positive number, if I'm multiplying my input X by a positive number, how is that impacting the graph? Look back at the example. What is that doing to the graph? Can anybody tell me? I'll give you a hint. Since it's attached to the X, it's going to affect the domain. So it's a horizontal what? If A is greater than, absolute value of A is greater than 0, it is a horizontal what?
Compression.
Well, it's a stretch. But I like that you're thinking stretch. Oh, no, sorry. A is positive. It is a compression. Yes, it's a shrink. Yes. It's a horizontal compression. And what about if it's a fraction? Well,
That's a stretch.
it is a stretch. And what if A is negative? What happened to the graph? For example, if I had f of negative x, what was happening there? Can we explain that transformation? What happens if we're taking the opposite of the x values? What was happening to the graph? Eric, can you tell me, anybody?
Would it be a reflection?
A reflection about what? Across what?
Across the x-axis?
We're changing our x's. So it's a reflection. Our positive x's become negative, our negative x's become positive. So it's a reflection across the y-axis, right? Does that make sense, Christopher?
Yeah.
Okay. All right. Now let's do the same thing for if A is outside. So it's impacting our y. So if our A is on the outside, well, again, we have to look at if A is positive, if A is a fraction, and if A is negative. What's happening? If A is a positive number, well, we're impacting the y, so it's going to affect the vertical aspect of the graph. So what is happening? If A is a positive number, it is a vertical what? Can anybody tell me? I'm multiplying my y values by a positive number. I should say greater than 1.
Vertical stretch.
Mm-hmm. And let me change this to 1, 2, because that's kind of confusing. Vertical stretch. Okay, what about if it's a fraction? It's a vertical
Compression.
shrink or compression. And if I'm negating my y values, if my y values are positive, they become negative. If my y values are negative, they become positive. So what's happening to the graph of the parent if A is negative?
It reflects across the x-axis, I think.
Beautiful. Excellent. Now, let's go ahead and take a look at what happens when we negate our x in general. It kind of has to do with this one, right? When A was negative, just like this one has to do with when, oops. So it's kind of a little redundant, right? Because we've already explained it. So what would this be? Based on what we said above in number 3. If I make my x negative, what's the transformation? Eric, can you tell me? Natalie, Christopher, what happens when I have a negative in front of my x again? Remind me. I'm changing my x values from positive to negative. So what's happening to the graph? If I have an x value here and it moves over here, what's happening? Or if it's negative and it moves over here, right? This is positive x, this is negative x. What transformation is that? Oh, heaven help me. What is that transformation?
Is it a reflection over your y-axis?
Yes, it is. And based on number 5, can you tell me what happens when I take my y value that's positive and I make it negative and vice versa?
Reflection over x-axis.
Yes. Okay. These were a little bit more specific. We kind of talked about how we were looking at only positive y's. Only positive y's here. And then here, all negative X values became positive. Everything else stayed the same. So really, the first 6 you should be able to recognize immediately. Okay? So we're going to start off tomorrow to see if you can, we're going to play a little Desmos game at the beginning to see if you really understood what I was saying with respect to these. So we'll see. Try to make sense of them, sleep on it. You know, you really should be able to look at any function. For example, if I give you y equals x squared as the parent, and I said, okay, fine, take this parent and add 4 to it, you should immediately be able to tell me we've done what to the parent to get the image. Can you tell me immediately what we've done? We've shifted it up. Yeah, we've shifted it up 4, right? Or if I take y equals x and I subtract 3, you should know that this is a shift to the right 3, right? So you should immediately be able to look at any equation and first of all, tell me what the parent is underlying it, and then be able to describe the transformations that yield the image function. Okay, so we will start with a game with that tomorrow, but you know, I have to show you, we have to finish with a picture puzzle. So let me go ahead and pull up my picture puzzle that I put in there. If it wants to pull it up. Okay. And we had, I think it was, where did it go? Oh no. Did it not save? Oh no. That's terrible. Oh no. We did the bananas. We did that one. Oh no. Let me see if I can send it ever so quickly, just so you can have it. We have to end with a picture puzzle. Okay, here we go. Let me send it again. There it is. Let's go ahead and work that one out. We figure it out. So tell me, we're going to tell me how much a soda is, how much a burger is, how much fries are, and then what the final answer is. Raise your hand when you think you got it. Okay, as soon as Ariana thinks she has an answer, we will go over it. Okay, so how much is a soda worth?
10.
Okay, how much is a burger worth?
5.
5.
How much are the fries each worth?
1.
1. So therefore, a burger plus fries times a soda is how much?
16.
15.
15. Good job. All right. Let's go bring some closure to those transformations, and I will see you tomorrow. We're going to start off with the Desmos activity to see how well we can recognize those transformations. Then we're moving on to the next topic. Y'all have a wonderful rest of your day.
Bye, Miss. Have a good day.
Bye, you too.
Bye, miss.
Have a good day, miss.
Um,
Bye.